So, ladies and gentlemen, the motivation for our panel today is we were looking at the topics that came in, and we observed a really interesting diversity of the types of data set that people are working with in our domain. This morning we saw a lot of really fresh research using mobility data, taking your GPS coordinates, your accelerometer from your cell phone. We're also seeing some remote sensing presentations this afternoon. We will hear later about a new tool for identifying tree cover in cities. And a lot of the work in urban informatics still relies on more traditional data sets, which you get off the internet using your laptop, whether it's census data or other agency administrative data. So really the theme is that for our cause of making cities better, people are increasingly using these very diverse and heterogeneous data sets, which opens up all kinds of different questions about what are they useful for? Are we beginning to encounter overload? And how do we harmonize and bring together data sets that are coming from really very different sources? So we have a wonderful panel, cross-disciplinary panel with some rockets, some pockets, and some pocket, yes, indeed. And our structures, we will have 3 rounds of questions. We're going to start out talking about how the data landscape has changed and how rocket, pocket, and socket data has increased in its volume in the past 10 years. And then we'll go to a second round, which is talking more about the challenges and barriers that we have when trying to go from this data to insight and action in our cities. So with that, I wanted to first of all ask a question to Marta, which is, so Marta, your research using cell phone data and GPS has been really defining in the field. We've seen some of your core kind of physics-based research published in Nature, which has really shaped the way people work with this data. Can you talk us through the growth of cell phone-derived data, and how are people trying to put that data to use in cities?
Yes, I think the latest amazing growth that affect directly the audience here is the LBS data. So all got started with CDR, Cold Detailed Records, and now with the caveats, like Ed Snowden beautifully and perfectly mentioned, that it's a mess how the data is governed. However, one aspect of the point is being in science and engineering, we are fed and driven by knowledge. And these data sets, we gave up our privacy to get instant access to the information, but this data set as it comes, my roles in the beginning was how we put it in the service of the people that generated the data, meaning planning for social good and the health type of applications, human-natural system interactions. These 3 things are a must, and we really, really need the data because the fields were so slowed down for it. Then we published the work with CDRs. All the companies knew the power of the data clearly, not need to tell about it. In these type of venues, the researchers sitting in this audience is the ones that still need to be working on this. And we saw the LBS much more available than the CDRs. That's the type of change I've seen in availability.
Fantastic, fantastic. And then Ran, so as a remote sensing specialist, can you talk us through your perspective on the growth of remote sensing data in the past 10 or 20 years? And how are people beginning to put satellite-derived imagery from various different sources into use for city decision-making?
So yeah, I think that, everybody is talking today about big data, and we are talking about big geodata, which is the data that has a spatial dimension. And the 3 V's that are relevant to big data, variety, volume, and velocity, are also relevant to big geodata. Millions of satellite scenes are captured every day, every minute. 3.5 million Lancet scenes have been collected since the 1970s. All this data is now publicly available and accessible for analysis. We're talking about different types of data. Some of the data is electro-optical, some of the data is radar. If we're talking about big data and big geodata, then we also need to think about the challenges. Where do we store all this data? How do we analyze all this data? And there are more and more platforms that allow you to do all the analysis on the cloud. For example, Google Earth Engine, which stores all the data, and you can implement some very easy to use algorithms. I think that another trend is data fusion. People now understand more and more that in order to solve problems, in order to understand our cities, we need to fuse different types of data, electro-optical, radar, daytime imagery with nighttime imagery, satellite data with other types of data, for example, cell phone data. One more trend that I see is the move from using products to giving the researchers or the policymakers tools to create these products. So in the past, we used to rely on existing remotely sensed products, for example, map of all the urban areas in the world, which was updated as of 2012. So it is limited in time, limited in space. Now there are more and more easy to use tools that allow you to analyze this data and extract this meaningful information across space and across time.
So moving to the perspective of a city practitioner. So Nick, sitting in the city government in Chicago, would it be correct to say that the data environment is very different today compared with what you had 10 years ago? And is it more a case of information overload, or is the city really able to extract some actionable information from what it now has?
So I like to think about it from a point of perspective of what really is a city, and using the city of Chicago as an example. It started about 200 years ago as a small settlement where a river met a lake in a prairie land. And today it's basically a large corporate conglomerate of $10 billion in annual revenue that has to manage 2 international airports, one of which is one of the busiest in the United States, take care of safe drinking water for the 3 million residents and millions of surrounding suburbs, manage highways and roads and so on and so forth. The list goes on. This is it's a lot to ask of an entity. And then once it's 200 years old and has established practices that have been going on for a long time, I think it helps put in perspective the data question. Absolutely, it's changed in the last 10 to 20 years. Having started right around 2000 in state and local government, I've been in and out. I've seen the evolution go from, at the beginning it was just moving paper processes to computers. That was like 5 to 10 years, and that's actually still going on today. And then with the new systems being built, what we were going to do with the data wasn't even a thought. It was, let's just get the data saved. It's only been recently in the last 5 years or just a little longer that we're starting to take that data and unlock the potential of what it can do. But then it led very quickly to those difficult questions of that we were talking about earlier of you can't just deploy a model and walk away from it. These things need constant attention, and they have unintended bias that we have to check and be transparent about. So yes, information overload, yes, things have changed, and yes, we are able to get insights that we haven't been able to get before in order to do things differently.
And Nyalleng, picking up on that, I'd like to ask you about your current work at Google AI Africa. So it's a lab in Ghana, relatively new as I understand it. I imagine you have all of the data resources of Google at your fingertips, so quite a lot. And you're facing some very interesting questions in African cities, which are changing, which probably face some distinct challenges. How do you see the growth of data impacting urban policy where you are?
Oh, wow. Yeah, so it's interesting coming. I mean, there is definitely the data in Google. Sometimes actually the biggest thing is actually trying to find it because it's so much and there's so many types of Google inside Google. So we are actually just a research lab, actually. The only Google that is in Ghana is their AI research, and so that's the one. And that side of things are a lot more academic. It's more like academic research, so not really product development. And if you were thinking about things from product development and policy from that perspective, it will look quite different from what we deal with. So for us, we work with the idea that we will eventually release the products to the community. And our community is primarily African machine learning researchers and perhaps implementers and policymakers in the area. So hopefully what we hope to get with having an entity like Google coming to Ghana and calling the lab the Africa Lab is hopefully getting to leverage the resources that are in the company to enable the researchers who are already doing the work on the ground. I was a researcher in Africa before I joined Google, and highlight these kinds of works that are already happening, but facilitate them to be done at the scale at which they have to be done, because Africa is massive and diverse. And I'm kind of grateful that actually it is the research office and not the product office that is there, because I think one of the biggest things that when you're working in industry and you're working in an industry that is in your home country, it's always this balance of knowing that you work for a profit company, but you want to make sure that actually you're doing good in your own, country or continent, and you're not being exploitative for this drive for profit. So overall, I think the biggest thing is to amplify the work that's already being done, facilitate the work to be done at the scale that it needs to, and influence policy that's going to govern the products and the inputs. So when and if all of them, all Google and Facebooks and Microsoft come, that we are there on the ground and are actually able to influence that governing policy. So kind of hoping that's what will happen with that.
Thank you. Well, that first round of questions definitely touches on the growth of data, but also the fact that we have some challenges in generating value from it. Ron, can I ask you your perspective on some of these challenges when it comes to interpreting the new resources we have from satellite imagery? What are some of the pain points or some of the difficulties in your field? And I might just cite one area that I know you've worked on quite a lot, which is urban flooding, for example. If we really want to help inform cities about which areas get flooded, what are the difficulties?
So a few challenges. The first challenge is the requirements. We said that there are so many types of data sets in different resolutions, 30 meters, 30 centimeters, 15 centimeters. We still don't know what is the optimal resolution to answer different types of questions. We do a lot of work also at New Light for FEMA, also in flood detection and damage assessment, and it is still not clear what is the optimal resolution that we need, for example, for damage assessment. Another challenge is in big data and machine learning, you need ground truth data for training and or for validation. And at least in urban research, it is very hard to get this reference data and to validate your products. Another challenge is, we are doing the analysis, we are the scientists. How do we bring this knowledge to the governments to really impact policymaking. How do we teach governments and cities to analyze the data? Regarding urban flooding, again, the problem, I think, is validation. Yes, we know how to utilize different types of satellite data to extract flood extents, but it is very hard to validate the data, especially in developing countries where you don't have ground truth data for the validation or reports from the ground. And concrete example of a challenge is in urban settings. Because in some of the research projects, we rely on free satellite data, for example, Sentinel-1. Sentinel-1 has many limitations because of the sensors. So it's very hard to detect, for example, flood extents in urban settings. And then you need to rely on expensive SAR data, LiDAR data, which is typically not available in developing countries.
So clearly we are trying to make use of new data from, you mentioned LiDAR, I think you mentioned SAR, yeah, so which is the satellite radar data. Also in Chicago, I believe you have had a lot of very interesting experimentation, partly with the universities there, on bringing some quite interesting sounding new types of sensor data into the city. Are you seeing a lot of value from deployment of sensors in urban spaces?
Yeah, so I think the biggest value is coming in that previous to these sensors, the types of data that they're measuring was only available at a larger scale basis. There would only be a few different measurements for an entire city. And now the sensors are starting to give us an ability to look on a more micro granular level to understand the real differences between neighborhood to neighborhood, block to block of measurements that used to just look at an entire city. And so it's opening up an entirely, it's not going to say new research, but taking research that's been around and being able to do it on a more micro basis to really make an impact in people's lives because we're all people who live in neighborhoods next to each other and we all have different environments. And I think that's what those sensors are starting to get at.
So I want to come back to one more topic in Chicago that you alluded to in your talk, which is the rise of Uber and new mobility schemes. And I think Marta will have a lot to say on that as well. But before that, I just would like to raise the topic of openness in data. So Nick, you really highlighted the value in Chicago that comes when the city puts all of its data sets out there on a portal, throws it open to civic groups, throws it open to research partners to generate new methods and models with. I wondered, Nyalleng, are you seeing openness of data as being important in your work?
Yeah, I mean, very. I mean, I don't know if underneath that question is saying, why doesn't Google also open? Okay, great. Okay, good. So we can push that to the side. No, I do. And interestingly, I started getting into spatial work because of the Chicago data set. Yep, the crime data set, that was from 2010. I think that was already posted, and that we wanted to see if we could do like better understand, this was where in South Africa, trying to understand the city of Pretoria, you know, and like how things move. And, you know, to build the first model, we used the Chicago data set. And then afterwards, then we went on and we used Twitter data to try and see if, you know, there were reports of you know, the crimes that were happening in the city. This was a long time ago, there are many things that can be very problematic from this study. I've got to say this up front. But interestingly, one of the outputs from this was just us learning about traffic flows in the city. But we also learned about this thing of incomplete data. A lot of crime is a private matter, and it does not get reported on Twitter. So you can't use Twitter to learn what crime looks like in the city. But a lot of people frustrated with traffic will tweet while they're stopped. So actually, Twitter is a really good way to learn about where, where traffic is blocked. So, we learned a couple of things through that. But yeah, even today, a lot of the work, for example, a lot of the work I do as a researcher has to be based on open data sets, because you're not going to publish a paper and then say people can look at the model and the data set. That doesn't go too well. So yeah, and internally, we actually do try to figure out if there's ways that we can share data in some form. So for example, one of the best ways that we can share data as researchers inside Google is to release a model, a pre-trained model. You don't see the original data, but actually you get a model that has been trained over that data set, and it's now up to you to refine it, fine-tune it with the data set that you have, which if you only have small data set, that really makes a difference. So it's one way of trying to work within the constraints that we have and trying to find out how we can give back to the community that gives us so much in terms of both the development of new techniques and also these data sets.
And I believe Google has just launched a new dataset search function, which
Yes.
seems fantastic.
Yes.
Last night in the keynotes, there was quite a kind of doom and gloom perspective at times about the growth of data and what it means for us. But it would seem to me potentially quite an optimistic story. In Africa, for example, I imagine with a lot of this new data, including remote sensing data, we're able quite more quickly to get a grasp on some of the challenges.
Yeah, there are so many entities that are working either in data collection or, remote sensing is one that is deployed all the time. Cell phone and also insurance, that's actually another one that's very rich in Africa, in terms of trying to understand the city. Telecoms don't also share their data, so it's kind of hard to get to that. And also insurance companies don't usually share their data either. So it's very interesting because the data is there. The data definitely is there. And the nice thing is the data is a new type of data, right? So when we are thinking about disease data, we're learning, we're studying different diseases. When we're thinking about crop data, we're looking at things like cassava, not wheat. And so we are actually being able to push back, into the rest of the world of machine learning and give them a richer data set that's just coming from, people like farmers trying to understand diseases on their crops or something like that. And then suddenly there is a whole report with thousands of these leaves. So yeah, I think for us, the biggest thing is going to be to design mechanisms which allow people on the continent to label their data. Because it has to be labels that make sense in the continent, right? If we can get to a point where we can label our own data and evaluate the goodness of a model in a way that's actually practical for us, then I think, that actually will be a great step forward into practically using, data science or machine learning to just alleviate some of the problems.
So I wonder if Ron and Marta have a comment about openness of data. So availability of open data sets doesn't come easily. I know someone like Chicago, creating one of those city open data repositories requires a lot of work, standardizing definitions, creating metadata formats and so forth. Are there limits to the degree which we'll be able to access your types of data in future? And are we doing enough to get open access to your types of data?
Yeah, so I will go back again to Google Earth Engine. Because I think the beauty of Earth Engine is that you have access to the entire data set, the raw data set, and they also encourage researchers to publish their products and their tools. So yeah, I see more and more openness in products and in codes and analysis. Also in reference data and ground truth data sets. OSM, as we will talk in the next talk, is a major part of it.
Yes, I want to add kudos to Chicago dataset. It's a just experience for the last semester. I teach a model on ODs that is called radiation, and it has to do the type of models that only use population, and it's used right now, for example, to the new coronavirus, the MOPS lab at Northeastern, predicting. Then they need to do ODs for the planet. Then with the World Bank and the World Pop data set on population, you can do those. Then I teach that model because it's relevant. My students need to do a class project, and they got the Uber data from the Chicago site. They did a fantastic model that killed the naive physicist model and learned, yes, it was embarrassing, and learned a lot. Of course, the conditions were different. They had the perfect training, and the demand for, when it's raining, it's going to go down, up and down, and then training testing.
Right now?
Huh?
Let's do a commercial. Let's save this.
No, the old PhD comic professor was going to, I took a picture of your last slide with mobility, was going to send to the student. This was an undergrad. This is the craziest part. This is a graduate class, an undergrad, and 2 more graduate students. The interdisciplinary team came with this solution to do at least a paper together. That's a PhD comic way. And then the students probably, and who knows, those the commercialization, but it's the ability that they just went ahead searching for data. They found the Chicago fantastic repository, and they could learn and surprise the PhD old comic professor. Let's continue doing more of that. I think on that regard, and notice it covered industries, cities, students. We need way more of that. The second thing I wanted to say, what is extremely inspiring about this workshop, kudos to the organizer, is the shared vision. So we are thinking big, in the big picture. We're thinking in solutions. And we're doing all what it takes to get there. And then I want to mention that in 2000, speaking about all, in 2006, when I started my postdoc, it only took one visionary person from a European undisclosure country that gave us the phone data, and Nature put us in the cover. It created the wave of people working more and more in phone data outside the phone company labs, that in computer science they were doing some work, but everybody, the physicists and the environmental scientists, and everybody doing the phone data, was a visionary that gave with non-disclosure agreement. We didn't put it in a web page. But then for the companies sitting here, you need to think different from the rest. Look for the mechanism such that we create a common knowledge for the vision we want to push. And in this case, it's cities, better cities, right?
Well, maybe we can talk a little about how some new data sets and analytic methods can solve some of the really tough challenges facing cities in the next 10 or 20 years. So Marta, you had a fantastic segment in your talk about electric vehicles. They're coming, and they could be a disaster, or they could be transformative. And Nick, meanwhile, I know that you guys have pretty hands-on experience dealing with the rise of Uber from 0 journeys to 1 billion journeys. Maybe, what's your perspective on mobility data and the challenge of mobility in Chicago?
Sure. So I'll get onto that, but first, when I first looked at AV and connected car data and what it would look like to house and store and collect some of that, about had a heart attack. My jaw dropped when I saw the volume and the transformations that would be required to actually do something with the raw data. So I think what we have coming with that is going to be a real challenge to deal with the size. These cars are generating an obscene amount of data, and that's going to be a thing. But the here and now, have had some experience in collecting data from lots of different mobility providers, like the Ubers and the Lyfts, and bike share providers. And this past summer, we had a scooter pilot and got to experience that. And I think what was interesting there is since scooters were one of the most recent developments for cities to actually put on scooter programs, that when those came about, the city of LA was really forward thinking and came up with a mobility data specification to say, hey, all these companies are going to be giving cities data. Let's create a standard so that we only have one type of data to deal with. And they did a fantastic job of designing a standard and getting it out there so that when we had a pilot of 10 companies last summer, we had 10 streams of data coming at us, that they were at least all lined up with a standard. But it's still a challenge. There's with it being a new standard, there's not always agreement on what fields mean. They're just raw data still. Then you have to build metrics on top of it. Everybody's interpreting the data in different ways. People are running to standards companies to try to be the first to create metric standards so that when cities are interpreting this raw data that we're all talking about the same thing, like a fleet count, how many scooters are on the ground at any given time, what's the size of the fleet. There's so many different ways to interpret this, and you come to wildly different numbers. There's a cottage industry that's forming around the data specification of companies that didn't exist a year ago that now have millions of dollars in funding that are selling their products to help ingest and understand this data. And they're not all agreeing on the same thing. So it's a real-time challenge that all cities are facing as they're endeavoring in micromobility, mobility across on the whole. And we're still grappling with how to receive all this data, store it all, and handle the different ways that it comes in, and then turn it into something useful. It's a constant exercise.
I think that another major challenge is how do we make the data accessible to those people who really need the data? I mean, if we will do all the analysis and we'll keep it on our computer or publish it in a fancy Nature or whatever journal, those who really need this data to understand inequality in their city will not get this data. So we need to make sure that they will have the accessibility and ability to interpret this data.
Going back to the vision as a transportation planner, imagine for a second that we had all the data points, storage and clean, and we know where everybody is. Still, the question is how we use this for a better city. Then we need the vision. So it takes a village, the whole layers. But let's keep, it takes a village to answer the question. And we need to keep in mind, depending on the question you are tackling, you need certain things. Always remember the sciences. You have statistical physics or thermodynamic laws, and you have quantum mechanics, and you have astronomy. So it's completely different depending on the question. Going back to the transportation planning, which is a mesoscopic aspect of it, is data informed, your data are validated, but then the big question is at the end of the day, the urban form, how it's organized, how people is commuting, and then we need to tackle the ways we're going to be the transportation. And at the end of the day, car shared, carpool, the information to distribute the cars that you get and you move, and not everybody have your own car, is a good solution, or the bikes. So we need to always keep the vision of the system understood by the numbers to propose the solutions to the policymakers. The challenges for this is, I cite face recognition, good. I cite the challenge you mentioned is, what's the optimal resolution to get the information? How we validate what we are proposing for each case? And then how do we bring the change to government? So you need to always pose the right question and focus on these three and solve. But of course, then it doesn't mean that it's one way. That is one type of question. Depending where you are, you're going to get your set. It takes a village.
So last question to Nyalleng, and then we'll do some Q&A. If you could task the machine learning researchers at this conference with cracking just one challenge in Africa over the next few years, what would it be?
Wow. One challenge. This is a personal interest challenge. This is not, I don't know if this will be the most useful, but language. I love language because there's so much culture in language. And Africans have so many languages. And we speak the languages. They're very utilized. Even though it doesn't always seem like we speak the language, except like during those exotic times, like when you look from the outside. The other thing with the language is that there are geographical relationships between the language and the map, like between the languages. So you can almost see a pathway through Africa, or just based on the languages. I'm sure it's true in other places too. But like also with us, we've got these little hubs and these little places that like this one people have been living on the other side of the river, and they have this one language that's so different from all the other areas that are around it. So if it was for one thing, I would say language. And the upside to this is there is a lot of language data in Africa in the form of radio. Almost every small town, village, whatever, has a radio station. And they've got all these tapes and tapes and tapes and tapes of this spoken language. So yeah, I think for me, that would be that. If we could understand and build better models for African languages, I think that would be fascinating. I think that would be more representative than the borders we currently have, the language borders.
Fantastic, love it. Wonderful. So we have 15 minutes for some audience Q&A. I believe Tino is going to kindly go around with the microphone. So please, put your hand up.
Already, perfect.
Yeah, so, well, I have many questions. But the first one I want to say is you're not really reflecting on what Snowden was saying last night, that we don't have a data protection problem, we have a data collection problem. You're not dealing with that, right? I mean, 50 years ago when not me, but someone would call someone on the phone, it was an analog telephone, there would be no record of who called who. But today, when my son calls me or when I call someone, it's all there on the internet, and it will stay there for years because there's no policy really around data collection. And that's what you assume that all your data is available there for years and years so you can do your research. How's that matching Snowden?
We do. Yeah.
Yeah. So we talked a little bit about the types of mobility data that we collect in the city of Chicago. And as we move forward in that, we've realized that there are times to not collect. There are instances when we've really started to line up what's the need. Is there a need that creates a public benefit? And if so, then we balance that against privacy interests and then define the granularity of the kind of data that you want. If there's not a need, then it ought not be collected. And so there's been instances where we've taken fields that we've asked for and say, we don't want this anymore, we don't need it. There's no reason to get something onto our servers that we don't know what we're going to do with it.
Adding a little bit on that, you are right. There is the problem, and we are not attacking it into the root. It's nothing. If you see the logic or the philosophies, you are absolutely right. Notice that Snowden was working in the NSA 2010-13. My feeling, as my vision on my position on the situation is governments, that is where he was working for, is having that in a mind-blowing way, as he said, that nobody's saying it, by the way, but he said it perfectly. They could search phone towers in the planet searching for someone. The data was there by the government. Companies had made the revolution of the industry with the information age. For epidemic spreading, for traffic, we had to deal with the survey. That was 2009 when I started doing my work. It's absolutely impossible not to use this data to improve our work. So the position is data governance is not what we're tackling here, unfortunately. But at least teach the students, and what I get engaged on this is that so many students want to use this data for climate and cities, at least. Then I still believe in the younger generation, as Snowden said, that we will see what we do. But as it is right now, let's use it for social good. So, but for the social good, we say, and not the marketing social good. But this is extremely complex topic, I would say. But that's the position.
I'll try to be short. I think obviously, there's always the part where you are a researcher and there's a part where you're a citizen. When you're the citizen, and I'm a citizen, of the continent of Africa, I know very well about how things and rights can be abused. There's two ways. We can be incremental about the process, which means we can try to do better, right? We can try to implement policy. We can try to implement privacy measures. Or we can completely flip this thing and say, this is not a process that should exist at all. This way of monitoring, this way of trying to improve cities should not exist. I think this is a citizen question. I think we as citizens have to go out and decide where it should go. So it's there. And I think one of the biggest lag, though, with this has been the magic making of AI and machine learning. The fact that there is some distance. I think if we get as citizens to a place where we relate to the processes that are governed by AI and machine learning in the same way that we relate to the processes that are governed by legal structures, the law. We're not all lawyers, but as a citizen, you understand your fundamental rights. And I think we don't all have to be machine learning practitioners, but as citizens, we have to understand what's happening with our data and our stuff. And if we can do that, then I think we can at least have some oversight and try to restrict the harm. It's not like the law is fair always, but it has some boundaries on which we can function. But I think we have to make choices. We are both researchers and citizens.
I'll take my organizer privilege and add a tiny little thing. What was lacking for me yesterday also in the Snowden talk is the core assumption of that talk is that you are in the internet. And if we look at cities, and especially at cities in low-income countries, there's lots of people who are not on the map, there's no data whatsoever on them. And if we build models based on cities in Western countries, we're gonna continue to overfit to Western countries. We're not gonna have people represented, and therefore we need to put them on the map, but we need to avoid the mistakes that we made. So we need to put them on the map, but responsibly, and that's a massive challenge, I think. So I absolutely agree with you, but we also need to think of the people who are not on the map. And the next question is over here.
Hi, thank you. My question relates kind of to what Marta was saying towards the end about this vision, and how these kind of visions of or needs of government can be translated to research community. I think I'd probably use the word purpose. Currently, as I understand it, and as I've seen it, policy, the interaction between policy and academia is usually either incredibly divorced or actually very well interwoven. So you have these projects that are really partnerships-based projects between academia and policy. And I wonder where, or there's a kind of them and us completely separated. And what I do know is that there's a vast capability funding within academia to do brilliant things. And I wonder whether there's a middle ground mechanism whereby we can take the kind of needs and purpose inherent in government and use that to co-create and co-shape an agenda in academia, but also in technology firms, so that we don't kind of have to either go really intense and clunky or completely divorced. And I wonder if that is something that you have seen work anywhere, or how we can start to genuinely co-shape these agendas.
Yeah, I think capacity building is the key here. Teaching the governments and cities how to use these tools and how to use this data to improve their decision making. Increase the awareness to the data sets, to the analysis, to the limitations of the data. But I think capacity building and giving the tools to the decision makers is the middle point.
I remember the experience around a little bit after 2009 when I started teaching. It was the White House called a cities initiative. It was in the Obama time. And I remember at that time the Charlie Cattle, the Internet of Things, was just a baby, and he was invited, and the CASP from NYU. All those things that we are still working, and they grew up a lot. And I was glad to see the connection between the Internet of Things and Chicago, the city of Chicago. It's so fantastic how they grew up. And it started motivated by the White House at the time on cities. And they are, I teach in the US, but then they do in Congress, they do the policy and the studies. So with a supportive government, you can bring the academia, sit down, explain, go back. We all go to our centers and our cities. So it's beautiful stories to do this. And that really motivates, because sometimes in academia, and as everybody that did graduate studies, you are every day in a little thing pushing a delta, and you don't see the big picture. Then you have the research group. When we are really making it for apply things, I love working, for example, with the World Bank. They bring this crazy question that I open a project that I start working in South America and in Latin America and Africa out of interest, but invited by the World Bank and the Inter-American Development Bank. And always when I talk to them, they come with a more inspiring question. So it has to be open eyes from ears from both sides, but it's really powerful, I see. Let's see the next administration.
I think quick response, if there is one here, and we're also going to cover another couple of questions.
Yeah, so it's a great point. And I think the only thing I can add is we've seen a lot of our best collaborations come through schools that have public policy and data science programs together. Because if you have those kinds of programs in an area and you have open data portals, then when you have our students that are looking for projects for their work, and then what they find the data, and then they call us and they start saying things like, what do you need? Or they saw news reports and they say, hey, we know you have this problem with this department and it needs fixed. We think we can do something for that. So those are just two items I would highlight, school programs to go along with the open data initiatives.
Great. Another question over here, please. And anyone else with questions, please formulate your question.
I mean, basically, it's a response to the same problem. I think we have unlearned what we had, and that's unions and cooperatives. We had in the 19th century basically the same problems we have now with data, and we have to relearn this. So deliberation, as you said, Nyalleng, is a constant process, and it's not something that comes from government nor from corporates. It has to come from the bottom. And I think we have to recreate these forms and deliberate them there, and then we have leverage and we can do something with governments and corporates. That's the only way, I think. Thanks.
Response, another question.
Yes.
It is a question for all of you. I mean, what is your opinion, the next challenge, the big challenge? Where would you like to invest your mind research effort? What do you think is the next one? Is disease outbreaks, natural hazards? What is the next big challenge that we need to face in cities?
Maybe the use of remote sensing to monitor the progress of countries towards achieving the SDGs. Almost for each goal, you can use remote sensing to understand long-term changes. So I think this would be the major challenge, the major next step.
The the development goals are the challenge, I think. I believe the connection between climate change and urban behavior, doing properly so that we can take insights and actions and close the loop, explaining what's going on and the causal inference of what's going on in the environment through the human activities is one challenge that I would like to work in the next years.
Wow, that's a really tough question. But yeah, I guess for me, it would be a communication thing. I don't know if it's a city thing, but it's about using ML for cities. And then I would say it's a communication thing. And it's about how do we work better together, and how do we close the boundaries of what is actually possible and what like AI and ML are actually capable of doing, and what sorts of things should be done by social scientists and which sorts of things, or like other physical scientists. So just this sort of thing, I think, for ML in cities, in better understanding what is the truth outside of the laboratory of somebody's computer.
I would say what is data going to be able to do for income inequality, for wealth disparity, for poverty? The very issues that we've talked about, the differences between Western cities and undeveloped areas, apply within cities. Like cities like Chicago have areas where we're going to see the same exact issues in part of the city. We're going to have trouble from a data collection standpoint because we don't know things about certain areas. And so I think that's going to be our next big challenge.
We have time for a tiny last question if someone has one, else we would wrap it up. Okay, I think
we finished
Yes.
just perfectly on time. So please join with me in thanking our panelists very much.